Hello, everyone, and welcome to Harness the Power of Hybrid Cloud with AWS and Avere. My name is Ian Schofield, Partner Solutions Architect for Amazon Web Services, and I will be your host and moderator for today's webinar. In addition to my introductory presentation on AWS storage, we will also hear from Jeff Tabor, Senior Director of Product Marketing with Avere Systems, and Dirk Peterson, Scientific Computing Director with a leading cancer research center. Throughout the webinar today, we're going to focus on a couple different areas. We'll talk about the various storage options that AWS offers and how you can use Avere systems to complement these features. We'll also talk about how you can implement a hybrid cloud architecture and provide an example of a leading cancer research center who's running a successful implementation. First, let's start by covering what storage on AWS looks like. There are a couple of reasons why customers choose to use AWS's various storage options. First is compelling economics. With AWS, customers are able to pay as they go with no upfront investments. This allows customers to trade large capital expenses for operating expenses, and customers can benefit from AWS's economy of scale because we're able to obtain lower prices and pass these on to our customers. For example, with Amazon S3, which is our secure and reliable object storage solution, prices start as low as 2.3 cents per gigabyte and can go as low as 1.25 cents per gigabyte if leveraging S3 standard and frequent access. Second, our platform is easy to use. Out of the box, Amazon Storage Services provide you with reliable, durable backup storage without having to do complex capacity planning. By offloading this to AWS, you don't have to deal with the ongoing negotiations with multiple hardware and software vendors or do any specialized training. Additionally, you are no longer responsible for the maintenance of the underlying infrastructure or have to deal with transportation of storage media to third-party off-site locations for remote backups. Third, you can reduce your risk. By using some of the various AWS services, you can take advantage of the reliability and durability that we provide. For example, Amazon S3 gives you 11 nines of durability, and because you're not responsible for the underlying infrastructure, you don't have to worry about handling the physical media or physical destruction of the media. Fourth, you gain speed, agility, and scale. By taking advantage of the various AWS services, you can reduce your time to market due to not having to procure hardware and set up infrastructure. You can easily provision resources using the AWS console or using the API. And the AWS platform also allows you to scale nearly limitlessly to meet the demands of your business. And because you're able to leave all the heavy lifting behind the scenes to AWS, you can focus on your business and what's important to you. AWS offers a variety of low-cost storage choices, many of which have pay-as-you-go pricing options for added flexibility. In addition to Amazon S3, which we mentioned earlier, another common option customers choose to save costs with is Amazon Glacier, which is a secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backup. Customers can reliably store large or small amounts of data for as little as 0.4 of a cent per gigabyte per month. We also offer services like AWS Snowball and AWS Direct Connect and many others to help customers better take advantage of the various AWS services. We've touched on Amazon S3 briefly so far, but let's dive a bit deeper into what Amazon S3 is and what features you can take advantage of. S3 is storage for the internet. It's a simple storage service that offers users a highly scalable, reliable, and low latency data storage infrastructure at very low cost. S3 provides nearly limitless storage with a maximum object size of 5 terabytes. S3 currently holds trillions of objects and regularly peaks at millions of requests per second. S3 also provides various options for customers to encrypt their data, including both client and server-side encryption, as well as integrating with our key management service. S3 also allows for the implementation of lifecycle policies to move to Amazon Glacier, which we'll talk about next. We understand that data access patterns vary and change over time. We offer different tools to allow you to tier your data based on the access pattern for additional cost savings. Amazon S3 Standard offers high durability, availability, and performance object storage for frequently accessed data. As this data becomes colder, you can migrate it to S3 Standard Infrequent Access. This is for data that you access less frequently, but still require rapid access when needed. It offers the same high durability, throughput, and low latency of Amazon S3 Standard with a lower price point. And finally, when you need to archive your data, you can transition it to Amazon Glacier, which is a secure, durable, and extremely low-cost storage service for data archiving. It provides 3 options for retrieval of archives, ranging from a few minutes to several hours. And all of these actions can be handled automatically via lifecycle policies based on schedules that you define. Amazon Elastic Compute Cloud, or Amazon EC2, is a web service that provides secure, resizable compute capacity in the cloud. You can provision hundreds or even thousands of servers in minutes from any of our 16 regions around the world. Customers can leverage features like auto-scaling to match the demand of their platform. This elasticity allows for customers to save money by not having to over-provision for peak usage, but still be able to quickly provision new resources when needed. We currently support various operating systems ranging from Amazon Linux, CentOS, Ubuntu, and other Linux distributions. We also support various flavors of Windows Server ranging from Server 2003 to Server 2016. And with Amazon EC2, you retain complete control of the host operating system and can configure it to your specifications. We understand that supporting hybrid architectures is important, and we want to enable customers to easily use AWS as a seamless extension to their existing infrastructure. By leveraging services such as EC2 and S3, users can burst using additional resources in the AWS cloud. We also provide various tools such as VPC, Direct Connect, IAM, directory services, and many others to allow customers to move workloads between on-premises and the cloud. The AWS cloud infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. AWS is certified and accredited by a wide range of regulatory and industry bodies. Here are a list of key bodies that have either certified us, or we have a workbook of guidance showing you how to validate an AWS environment against these standards. And all AWS customers inherit all of the best practices of AWS policies, architecture, and operational processes built to satisfy the requirements of our most security-sensitive customers. Now, I'd like to hand it off to Jeff from Avere, who will talk about their offering and the various benefits it provides.
Thank you, Ian. Hi, everyone. This is Jeff Tabor. I do product management and product marketing at Avere Systems. And so Avere and AWS are teaming up to deliver a solution that we call Hybrid Cloud NAS. And so this is a diagram that we like to use. It shows all the resources that are available to a IT admin or IT architect when you're designing your NAS or file system environment. So on the bottom half, it shows the on-premises resources. And so on the left, it's your compute farm, some servers, maybe desktops and things like that. And on the right, it's the storage, which consists typically of NAS or object-based storage. So typically, when we get engaged with a customer, this is where their enterprise file system applications are running. And their goal is to incorporate AWS, which is shown at the top of this slide. So on the left, we have the EC2 cloud, the compute cloud, and then on the right, it's the S3 storage cloud. So the goal of the hybrid cloud NAS is to manage this whole environment in a very simple way and a very flexible way. So let me take you through 5 use cases that we sell to our customers. The first use case is called NAS optimization. And with NAS optimization, we put a high-performance flash tier in front of disk storage, typically from NetApp or EMC, and the goal here is to introduce flash into the environment. And so out the client-side ports of the physical FXT, we speak NFS and SMB, or the standard NAS protocols, and typically to the NAS solution, we'll speak mostly NFS. And so what the physical FXT does in this case is caches the active data. And typically this is only 5 or 10% of the total data. And what this allows you to do is offload the NAS and then optimize that for cost and manageability. So you use like large and slower drives like SATA, and you kind of centralize the NAS in an area that is less expensive for you to manage. So the next use case we call file storage for private object. And that does exactly the same thing as the NAS optimization with one additional piece. And that is we translate the NAS protocols that we serve on the client side to S3 API protocol on the back end. And this allows customers to build out their private clouds in their on-premises infrastructure. But now that we have S3 API support, this enables us to connect into Amazon's cloud. So our first step was to connect into the S3 side of things, and with a use case we call Cloud Storage Gateway. And so here we are adding up to 50 of the buckets in Amazon S3 into the namespace that's created by the Avere system. And this use case is really attractive for people who are, basically drowning in data in their data center, or they are just like or looking for a more flexible and quick way to provision 10 terabytes or 50 terabytes of data for users. And so they can do this all not in their own data center, but leverage the equipment that is in the Amazon data center. Because people, when they're moving to the public cloud, they're trying to get out of building larger and larger data centers. Similarly, on the compute side of things, we have a use case we call cloud bursting. And in this use case, we utilize a software-only version of our product we call the virtual FXT. So you basically use instances that are already up in the compute cloud, as well as SSDs that are up in the compute cloud, and you get all the same benefits that we provide with our physical FXT, just not on our hardware. And what this allows you to do is stand up large volumes of compute nodes to help you with your demand that arises at peak times. And in this use case, you don't really need more storage. The storage, you've got plenty of storage in your on-premises data center. The main driver for the cloud is to use the compute. And then the last use case we call Cloud NAS. And so that's sort of the holy grail where everything is moved into the cloud. So you put all your data in cost-effective S3, and that's where 100% of the data goes. And then the 5 or 10% of active data we cache in the virtual FXT, and your applications have really low latency access to the data that's cached there. Let me move forward. So talk a little bit about the software functionality. So we are, as I said before, we're a NAS product, we're a file system product. So let me just run through the list of features here. So we provide a very, very compelling and powerful GUI. This is used for both setting up the equipment in a very simple way, as well as monitoring what's going on the client side, on the storage side, internally inside the cache itself. We are kind of a complete NAS solution, so we support NFS, SMB, and multi-protocol data access. And this is to enable customers to use their Linux, to use Unix, to use Windows, to use Macs. So we support the whole range of operating systems. Snapshots are important functionality for data protection. We have those. Global namespace is an important thing. We enable all of the NAS and all the object and storage systems and all the buckets in Amazon to be mapped into a single global namespace. And so you can essentially, clients can mount on one mount point on the Avere, and then they can see all those other storage capabilities through a single namespace. The migration and mirroring are pretty slick. They are for moving data and mirroring data across those different core filers, we call it in the Avere architecture. And then, second to last is compression. You want to be efficient about storing data in the cloud, and so compression will make sure that the data you're storing is compact, and as well as encryption will keep your data secure. And we support KMIP protocol, which means you can manage your encryption keys on premises. So let's talk a little bit about the hardware. There's two types of hardware. So first, there's the hardware that's already in the AWS EC2 cloud. And so there are two instance types that we support today. So both of them are R3, so they're memory intensive instances. So there's the 2 extra large, and then there's 8 extra large. So memory is very important in the way our software works, because memory is where we hold the hot data. And then on those instances, we provision either 1 terabyte or 4 terabytes of SSD from within the EBS, so like a general purpose SSD functionality. And that's where we keep the warm data. And so warm data is either data that was previously hot, or we are, based on algorithms running in our product, we expect to be, hot soon. So when we have a large cache up in EC2, what that guarantees is a very high hit rate. So you're not really going to the core filer, because the core filer can be on a very high latency path. It can be all the way back at your data center on like a NAS system, or it can be in an S3 bucket, and therefore, while that's still pretty fast, it's not as fast as the SSDs that are in EBS. So the other type of hardware is the physical hardware that we ship ourselves. So we have a lineup of small, medium, and large products in what we call the 5000 series. The 5400 and the 5600 are most similar to the instances that in AWS, because they're all SSD. They provide a bunch of a good amounts of memory as well as SSD. And then the 5200 is sort of a little bit different animal. It's for smaller, less performance applications like remote offices and active archive. So we take performance very seriously, and so most of our systems, especially the high-end systems, get sold into performance based applications. And so whether this can be genomics, this can be financial simulations, this can be rendering. And so the 5600 and the 5400, I know the slide just says 5600, but the 5400 has the same functionality. They deliver 4 gigabytes per second of read throughput per node. And so in a max cluster of like 24 nodes, you'll get 24 times 4, which is 96 gigabytes per second, which is pretty fast. For like metadata operations like GetAtter, we do 400,000 per box, or 9.6 million in a large cluster. And then for data ops, we do 100,000 operations per second, or 2.4 million across a large cluster. And so the other nice thing about our solution is it's very compact. So it's just a one-use server per node, because when you've made the decision to sort of move into the cloud, into the public cloud, you're sort of done with filling your data centers with like large arrays, and so we try to make the system very very compact and efficient. So in closing, Avere and AWS are teaming up to deliver a very compelling hybrid cloud NAS solution. So if you're looking to add capacity, and you're concerned about the performance, and you're concerned about the space for the storage, we can help you there. If you have a file-based application and you're looking to enhance the performance and looking for servers to run it on, we can help you there as well. So our goal here is to build a cloud strategy that makes sense for your business. And so with that, I'm going to pass the mic to Dirk Peterson. Dirk is the scientific computing director at a leading cancer research center. And so with that, please take it away, Dirk.
Thank you, Jeff. Hi, this is Dirk. Thanks for having me. I'm going to tell you a little bit about our specific use case in a scientific computing environment. I'm responsible for the research computing part at a cancer research center in Seattle, and we have about 3,000 employees. And for the specific infrastructure that we deploy, it's always important to know that we have many independent research groups that follow their own trajectory, that follow their own goals, and they may have very diverse needs that very rarely can be covered by one single specific solution. You typically have an array of solutions, and you hope that you don't have too many of them because you really want to cover a broad range of use cases with your infrastructure. we're government funded, so that means we don't have unlimited budget. And we're also doing more than just cancer. HIV, infectious diseases in general, is a big focus here. And we have decided to move to the public cloud in entirety within 5 years. We may not be able to reach that goal completely 100%, but if we are reaching 80-20, so 80% cloud and 20% on-prem, then I think we can say that we're also quite happy. What are my main challenges right now? It is providing sufficient amount of compute power for the right cost at the right time. And here you see that our workloads are pretty bursty. So you can see we have an HPC cluster that has roughly 1,500, 1,600 compute cores in a public segment that is available and shared by everyone. Workloads are not always the same. People have grants, they have application cycles, typically ahead of annual meetings when folks want to show off what they can do, then the utilization spikes also, but it's not always 100% predictable. We have a 60% CPU utilization on average, so per se there's not really a need to expand, except that we have long periods of time where the cluster is really busy, and so if we would just buy more hardware, then we would have even more times where when the machines would not be busy at all, right? So that seems like that sounds like a good use case for cloud computing. And here you see where the yellow jobs, those are like pending jobs where people are waiting, and sometimes they're waiting for weeks, for 3 weeks for their job completion. And if we could run that in the cloud, it may be a matter of hours if we can designate like 10,000 cores to that. So that seems like very interesting use case to engage in more cloud computing. The specific challenge with most cloud computing workflows, like take for example AWS Batch or other workflows, is that you have to re-engineer your workflows so they work with object storage systems such as S3. Typically, life science researchers, they only know mounted file systems. They have NFS or SMB or their Mac connecting to their resources. So they have to, in many cases, relearn. They have to like download the data from S3 and compute on it and then push it back. That's not impossible, but it requires a one at a time, often hand-holding and training for this. And so in many applications are actually not able to use object storage at all. So we still have the use for a legacy POSIX file system, and we think even though people are adopting object storage to a certain extent, that POSIX file system will not go away possibly in 5 years. They may not go away in 10, or they may not go away in 20 years in its entirety, because there's so many applications that have been written ad hoc that make use of these file systems. One example is the IGV, Integrated Genomics Viewer. It works very well with a file system. It also works kind of with an object store, but it has to be adopted, and it has to be like you have to read the manual really well in order to make it work. So in general, the same story you hear from others is focus more on the actual scientific need, not so much on information technology or the core underbelly of everything. Just make sure that people can use your infrastructure. When POSIX file systems are required, use Avere. Avere puts a POSIX file system layer on top of S3. It uses S3 as a storage backend. You won't be able to access that data through S3 directly. It's just like through Avere, but that's okay. It's a specific use case that is required by many researchers, right? The compliance of the cloud comes for free, and a big point for us is that's actually a most limiting factor right now. It's not even budget, is the IT talent pool in Seattle. The competition is really high, and it's very difficult to hire senior people in Seattle. What we are lucky about is that we have we can use a phased approach. We can do a one at a time, and so because we have many different researchers and different groups, it's quite straightforward to move a one at a time. the phase approach. Phase 1 goes with like lower on-premises NAS costs. So we have basically a physical FXT that we're using to connect to an on-premise object store. We're using SwiftStack for that purpose. Jeff already mentioned it, that use case is actually quite mature and well supported already. And then we go over like using compute resources and cloud storage to a full cloud deployment in phase 4, which is like the 5-year approach that I was talking about. So when we're looking at the details here, so the first use case was scale out NAS. We have we're using the same scale out NAS that basically almost everybody in life sciences uses, and that is not inexpensive. We can use a virtual, a physical FXT, a Avere FXT, to actually reduce the storage cost quite a bit. The performance is not 100% the same, but it's actually quite close. And over time, this can then replace existing NAS systems. Then another challenge is the cloud bursting that I already mentioned. So I have an on-prem compute infrastructure, and I want to use the cloud as needed. But all my data is local. So how do I get people access to that data and have that HPC cluster use everything transparently? And here the solution is to put a virtual FXT into the cloud, connected to our on-prem NAS, and whenever somebody runs a compute job, the data will be pulled across. The first iteration will be relatively slow because it has to traverse through the network. But then subsequent I/O operations will be very fast because they come from a flash-based cache or SSD-based cache. So the next solution ongoing is we have this issue that research teams sometimes come ad hoc with large storage requests that haven't been planned for in the budget. And the physical FXT with cloud resources allows us to address this very quickly. We can provision not just 50 terabyte, 100 terabyte, 200 terabyte, and then make this available very quickly. Then we can decide, do we want to continue to use it this way? Do we want to move to on-prem? At the moment, on-prem versus cloud storage, object storage is relatively identical in cost. The difference is not that large. The difference is in latency and performance. You still have on-prem storage because your connectivity to the cloud may not be as fast as you want it to be. So there's still some benefit, but that benefit will probably go away over time. In phase 4, you see on-prem compute and on-prem has completely gone away. Again, this is our goal. We're quite hopeful that we can achieve that within 5 years and then have a completely virtual FXT. We still believe at the time that we will need the Avere FXT, the virtual FXT with a POSIX file system in the cloud, because I said initially that we don't expect the need for a POSIX file system to go away for a very, very long time. So a quick look at our architecture diagram for this whole deployment. Maybe a focus on those like PI folders, principal investigator folders. If you see the number 10 in the bottom, we are using NFS AutoFS and Microsoft for NFS connections and Microsoft DFS, distributed file system, to allocate resources on a principal investigator or group level. That means for each group, we can use a different storage backend and still maintain a coherent view of like a single view or a single namespace for everybody, and we can make this very transparent. And with this, we can move data one at a time. So if we believe that the cloud burst Avere is ready to go for some, we move over that group and make that available on Avere. And then we take the next step. So this is basically a 5-year migration. It's also interesting that when you have a scale-out NAS system and you want to migrate away from it, you always have lots of nodes that are pretty new and that haven't reached their 5-year life cycle yet or their lifespan yet. So at some point you need to make a decision if you want to move away and not throw it away entirely, that you will buy no more new nodes and then migrate slowly to another system. And even though you make that decision, there's still a lag of multiple years until you can actually shut down that system. So those are very long-term decisions that you need to make there. So basically, lessons learned. We work with Avere professional services that allowed us to not have to deploy additional resources for testing. We developed a test plan, and Avere professional services executed it and reported on it. That required relatively little involvement from our side, where normally you have to designate one entire engineer for several months to actually do that. Some of the unexpected things were that our HPC workload manager that we implement for the cloud bursting, we had actually not expected that to be any issue. It wasn't a big issue after all because storage was the biggest problem we needed to solve. But despite that, the workload manager cloud bursting functionality was there. It was in the API, but it was not documented at all. And we couldn't find anything on the entire internet that anybody had actually done that already with AWS. That was quite surprising. So we had to implement that with a bunch of Python scripts. It wasn't a super big deal, but it's now available. And I may be actually happy to share that as well. If hybrid cloud is really not necessary, there's wonderful tools. If you don't have any hardware, don't implement a solution like this. You can use CS Uncluster in AWS. It works wonderful. You can also use AWS Batch, which works really well. You really need to make a decision on whether you want to do hybrid cloud because it is definitely more effort than just doing AWS straight. To summarize the hybrid Cloud NAS, it provides near enterprise performance. We're not quite yet at the performance that we have with our existing NAS, but we are still getting like gigabytes per second throughput, which is absolutely quite sufficient for us. It meets our requirements. We're having some smaller issues with like copying rsync over many small files. That's been a little bit of a challenge, but that's also improving. And one thing we really learned was also that when you build a VPC connection to AWS and you have 10 gig internet, that doesn't necessarily mean that you can actually use all that 10 gig. It's basically only 5% of that if you're using IPsec. So we are moving now from IPsec to an SSL-based VPN, which will actually be probably 4 times faster, so about 2 gig. And that's one of the things that we learned. And because the internet or the network connectivity is not that super fast, the Avere caching adds actually more value. I think I'm turning back to Ian right now.
Yeah, so thanks, Dirk, for giving us an overview of your solution. So now we're going to transition into our live Q&A. So to start off with, we have one question for the Avere team, and that's whether the virtual FXT, it has its hot data in EBS and stores its colder data in S3. And since S3 is object storage, are the real files accessible if I browse S3, or are they encapsulated in some type of VHD or other blob?
Yeah, so this is Jeff Tabor. It's in a special format, and so you can't go directly to the S3 today. So we do have a plan on our roadmap to make that available, going directly to the S3 buckets, but that's not available today.
Got it. Okay, thanks. And we also have another question for the Avere team. Do you guys support cold data stored in S3 that's undergoing lifecycle policies to move to Glacier? And how does a file disappearing from S3 while it's transitioning to Glacier, and what does that appear to the end user that's accessing the virtual FXT?
Yeah, so there's no Glacier support today.
Got it.
If I can add, there is though, and that's what we are banking on, you can basically move transparently to infrequent access in S3. So to give you a number, the standard S3 is like $25 per terabyte per month, and infrequent access is like $12, right, or less even than that right now. And so that makes it worthwhile. And this can be actually done with Avere and anything you want transparently in the background, because a NAS system doesn't even have to know about that. And so we are banking on those cost savings actually.
Got it. Okay. And we have a question for Dirk, where they're asking, in the last slide where you showed your VPN and VPC, they wanted to know what was the issue with the VPN in terms of network bandwidth usage, and what was the solution that you guys implemented?
So actually, it took us some time to come to the bottom to that, but the limitation is actually with the Zen hypervisor. There's a nice white paper that on a firewall vendor's website called Fortinet, and you can read up on that. So basically, the Zen hypervisor in aggregate only supports about 550 megabits per second aggregate IPsec traffic. I don't know why that is, but that's a limitation within the hypervisor deep in the operating system. And it only supports 175 megabits per second per session. So if you have one single session, it can be actually quite slow. And so the short-term solution to that is basically to switch away from an IPsec to a SSL-based VPN solution based on OpenVPN. So you can basically get a virtual appliance in AWS with OpenVPN and also put a physical appliance on-prem, and then you can actually get 4 times the performance. Now, that's not yet 10G, which we are hoping to get. We've also investigating AWS Direct Connect, but we don't have the full encryption for that. In order to reach something like HIPAA compliance, we are not yet sure if we can actually use Direct Connect. That's an ongoing discussion, and I haven't actually seen anybody using it for that purposes right now. But Direct Connect would really solve these problems, but we don't know if we can use it for compliance reasons. So hopefully that answers the question.
Yeah, and so Ian Schofield here from AWS, kind of tacking on to Dirk's answer. That actually is, we see a lot of customers, and it's actually a best practice that we recommend for customers when they use Direct Connect to layer some sort of encryption on top of that. So, either using SSL or creating an IPsec tunnel on top of that for that added layer of security that Dirk was mentioning. For the Avere team, we have another question asking if there's any support for user or group quotas.
I don't actually know. I believe that is a roadmap item for us, but I'm not 100% certain.
Got it. And we have another question for Dirk here, and they're asking, what's the scale of AWS compute and storage resources that you guys anticipate using both in the near term and the long term?
Ooh, that's a very good question. So I can say that I think we deployed, 1,000 nodes, so a couple of thousand cores in AWS, and then these are not running, right? So these are basically VMs that are deployed, and then we shut them down and or hibernate them, and when the scheduler says I need more resources, then those are launched and fired up. So I'm not necessarily concerned about the scale. I think we could go to probably a couple of thousand or maybe 10,000 nodes. The limitation is often more that you have to still contact Amazon. The cloud is, in theory, is indefinite, but if you really want to go up large, then you still want to tell them that you're doing that, so they are prepared for that. That would be my recommendation.
Got it. Okay. And we have one specific question for AWS here, and it's whether they can encrypt their data in S3. And so, yes, you can certainly encrypt your data in S3. If you need extra security, you can use our server-side encryption option or the server-side encryption with customer-provided keys. And you can use this to encrypt your data stored at rest. And Amazon S3 also gives you the ability to use the encryption technology for both those, as well as kind of integrating with our key management service. And this allows you to bring your own key material into AWS unless you don't want to use the AWS provided keys.
For me, I can maybe add one more thing to that. The encryption we're using, the AWS encryption, it works wonderful. It's great. It's transparent. It's awesome, with one caveat that it is optional. So you can choose whether you want to encrypt or not. And the upshot of that is that suddenly 75% of all third-party clients that you could use to access AWS S3 do not work anymore, because most of these clients expect it to be non-encrypted. Then you're a little bit out of luck there. But there's a number of clients that still support it. You just have to pick the right ones.
Perfect. And we have another question here tailored towards Avere. And they're wondering, how does the Avere solution differ from using the AWS Storage Gateway?
Yeah, so the Avere system is a clustered system, so it's just a lot more performance. I'm not really up to speed on the gateway, but I believe that's like a single node. I don't even know if that supports the like NAS protocols. So I apologize for being kind of a little bit ignorant on the gateway functionality, but ours is just sort of gateway on steroids. So it goes from 3 to 24 nodes and delivers massive performance.
I could maybe also add one thing to
Yeah,
it, because we evaluated, looked at the gateway for another purpose. So the AWS storage gateway is not really intended as a NAS solution per se. It is more like an on-ramping solution to get data into S3. So as opposed to Avere, where you have basically you're putting a blob into S3, every object that you send through the gateway is transparently available in S3. So that basically has some compatibility benefits. So if you want to migrate data to S3, the gateway is a great way, but it is not a performance solution because the translation between file and object is naturally quite slow and has a lot of latency, right? So it's an on-ramping solution, not a NAS solution.
All right, and Dirk, we have a question here for you, and they're saying, is it true that the scientific research side of the Cancer Center is migrating, but the operations side of the business is staying on premises? How are you thinking about it?
Is this true that this is happening, or is this, I didn't quite understand the question.
We don't have any additional clarification, but I mean, in your view, throughout this process, have you seen a rift in, either doing the migration or staying on premises, with the forwards planning as well as the existing operations side of your house?
I mean, I would say in general, the scientific side is definitely flocking more to AWS because it is more kind of, it's not as Microsoft-centric, right? And the enterprise side sees value in going into Azure as well. So we do multi-cloud. AWS is 90% of our cloud share right now, and enterprises see some value to go there as well. Yes. So the plan is particularly for enterprise, to go full cloud. I think that there are some use cases that are more regulatory for like some scientific data to stay on-prem, but I believe enterprise has no such reasons to stay on-prem, and they will go actually 100% cloud.
Got it. Okay. And we have another question that's asking what the main difference between object store and a regular file system is. And so to put this in the context of AWS, EBS gives you your regular file system. It gives you your block storage. And from there you can provision, your any file systems, POSIX compliance file systems to perform your typical operations. Whereas S3 is your object store, where you're strictly just worried about storing your individual data. You don't want to worry about the actual underlying file system. So it's kind of just a different way of storing your data and the level of granularity. You still have the ability to do different permissions. So with S3, you can have things like bucket policies and object ACLs, whereas your file system, you get your typical NFS permissions as well as whatever your file system provides. All right. Well, we're going to go ahead and wrap up today's webinar. I'd like to thank everyone for joining today, and you'll receive an email within the next 2 to 3 days with a link to these slides on SlideShare, as well as a recording of today's webinar. We want to thank you all very much for attending, and if you have any other questions, please don't hesitate to reach out to us. Thanks, and have a great day.